Nintendo Switch. I'll show you what's going on with it. Switch you over to the microscope. Houston, we have a problem. So, as usual, we will have to take this apart. We will have to remove that port because there is absolutely no point in testing anything until that port is off the board. Collateral damage is a distinct possibility, but I don't know. You know, we may get lucky. We've gotten lucky several times now, so. But we will not assume it. We will disassemble, take off the port. We are set up to take off the port, and we'll be back. Okay, I have the board removed. I'm going to say that I do have a little bit of concern here. And that is just from the general state of this heatsink. I think I want to inspect under there real quick. It's going to be something I may just start doing out of habit. To make sure I'm not about to waste my time on a mod. I'll break the switch. Just to be sure, we do not have evidence of a mod. Okay, we do not. Very good. So, when we're looking for evidence of a mod, let me switch you over to the microscope here. I have installed these mods, so typically you would see some solder blobs right here on the shield, and then there would be some solder around, if I can point it out, probably around this capacitor and this capacitor, but there is none, so we're good, and we'll consider it to be good. I was a little concerned because it seemed a little bit warped. Oh boy, I am not even going to change ports on those anymore if I can avoid it. All right, good enough. Okay, so let's set up to deal with this port. I will throw my temperatures up while I turn on my equipment. We have to remove this port before we can do any testing. All those pins being kind of bent together and stuff will do us no services. Okay, so we're going to do, so I get you focused in here. We're going to do what we always do. We're going to flood the area with low melt. I will go over one more time why I do this. Some people will say it's not wise to do on a USB-C, but what I have found in my findings is I've never torn pads using low melt on a USB-C. To be very, very clear. Not happened. Not even once. What happens is the anchor points wet and the row of pins that you can see wet, and then in practice, and then when the hidden row wets enough for the port to come off, it just falls off. It doesn't pull pads. I'm going in with full airflow, so when it's ready to go, it just falls right off the board. It gets blown right off the board. It does not do it before then. That's been my experience, and I've been using low melt since probably the beginning. So anyway, we're going to do what we always do. We will flood with low melt and go from there. Okay, looks like we have a good pull. Let's make sure we don't have any bridges on the other side. And we do. We want to clear those before we test. They will skew our results. Okay, no other bridges. I'm going to flip the board around because the rest of the work we'll be doing from the other side, unless we have problems on the other side. Alright, connect my meter, and we'll begin testing around the N92T36. I want to get zoomed out so that you can see. Trying to be more mindful of that, not always going to be successful. Okay. So as always, we'll start with the Pi 3 USB. This is the Pi 3 USB cap. It seems fine. And from now on, we're going to be checking. So if you look at the capacitors, there'll usually be a trace leading to the chip. There will be the occasional capacitor that has two traces. On those, one will be ground, but the rest should not be. This one is one with two, so one will always be ground. Okay, everything is checking out around the N92. Let's move up to our capacitors. I'm sorry, our MOSFET array kind of. Okay, everything seems okay there. Check our little filter. Everything seems good there. Check our fuse. Looks good. Now we're going to check all of our test pads, at least going to the battery. This one should be ground. Let me get that in view. This one up here should be ground. The rest should not be until you get to the battery. Okay, looking good. This one should not be. This one should be. Very good. Now we'll test around the BQ24193. Not shorted to ground, but it does have continuity. You want continuity through that coil. Now we're going to do the same thing. We're going to look at the signal side. Now this one here has two going to the chip. BQ24193. One of them will always be ground in that case. Same thing with this one. One will always be ground. Okay, everything looks good there. We're going to flip it over. And we're going to test around our Pi 3 USB. Every once in a while I remember the correct name. First thing we want to do is check our filters. Make sure they have continuity coming through, but we do not want continuity going side to side. Now sometimes these will have a manufacturer residue on them, so you may have to scrape it off a little bit to make good contact. Alright, everything was good there. Find ourselves a ground. And this side of the capacitor around Pi 3 USB should not be short. It's the one going straight to the chip. And it's fine. This side should be ground. So very good. It does not look like we have any collateral damage at this point. So we will clean up. And we will prep a port. We'll prep our pads and a port, and we'll put a new port on. Go from there. Okay, I think we're ready, clean enough to do a test. We will do a more thorough cleaning off camera so I can use my air compressor. But let's see what happens. There we go. Seems relatively normal. And that seems relatively normal. Very good. I'd say that's a good enough indication that we can put it back together enough to test. I will clean it up more thoroughly off screen and put it back in the housing, and I'll be back once I am ready to test. Okay, we're ready to perform a test with my known good battery. Plug it in real quick. Switch you over to this so you can watch along. Watch the PSU in the bottom left. Alright. Okay, full battery symbol. Alright, looks like we are charging. Let's try the other side. And we are charging again, fast charging. Fantastic. Okay, we're back up and running on their battery. And it's charging both Joy-Cons, which is good. Flip it around, shows charging on both sides. Beautiful. Alright, I'm going to set it for a dock test, and we'll check that and go from there. Okay, as you can see in the top left corner, we are syncing. That is great. That's great news. That means the port replacement went well. Okay, in summary, we had a severely smashed up port. We had to remove it to test for any collateral damage. We did not end up with any collateral damage, so we're very lucky on the customer's part. Replace the port. Everything's testing out great, and that's really all I have for this repair. If you have any questions about the equipment I use in this video, take a look in the description below. They're all linked down there. If you have any questions, please comment below. I'll get back to them as soon as I can. Uh, if you like this video, do me a favor and hit the like button on your way out. And if you want to see more videos like this, hit the subscribe button and maybe the notification bell, and you'll know when I post videos. It's usually about twice a week. That's really all I had to ask of you. Thank you for watching. We'll see you next time.